I have you here at the mill. I'm doing the final measurement to see how off the column is perpendicular to the milling table. I had this steel square calibrated at this point and this point, and it's off 4/10,000 this way here and off 8/10,000 this way here. And I calibrated this on my surface plate using this cylinder square, and this cylinder square is not accurate. So what I did, I found the highest spot here plus 5/10,000, and on the other side, this point here, minus 5/10,000, and then the zero, I swiped until I found what the zero is. So with the dial indicator mounted here, I was showing plus 5 here, and on the other side minus 5. So zero is whatever a zero is on the circumference, and I found it at this location. And then I checked against this granite square, and I'm within 1/10,000. So I did that at two heights, the one I have on the square. I could have got even more precise than 1/10,000 of an inch I have for this mid-to-tail dial indicator. I have here a micro cutter, Russian, sort of a dial test indicator. It's 0.5 microns, one of those small divisions. The bigger ones are 1 micron. So 0.5 microns is 20 millionths of an inch. And I could have gone even lower than that. This is 0.1 micron. So that's 4 millionths of an inch, the small division. And I could have measured and found, the squareness within 4 millionths. But I'm not sure if this is the diameter is accurate in that range. And then this is a mill, does have enough rigidity, and I don't need to be that accurate. So I think if I'm getting in the range of 1/10,000 of an inch or 25 microns for the stroke of the column going up and down, I think I'm good with that. So I measured for this distance here, which is exactly the same distance the column gets mounted here, this distance, and I found is a 5/10,000 deviation, and I put here a 5/10,000 shim. This distance from here to here is the same with the distance from here to here, this point. And it's a brass shim, 5/10,000. And now I'm gonna check to see where we are with that. So I'm gonna move to that first point. So we are at the first point, and let's see, we are pretty much on zero. And if I move up again to the next point, I have that 80. Here I'm off by, how much is that? 2.5 10,000, but I have to subtract 8/10, so about 1/10,000. So I'm off about 1/10,000 for this full length, and I can live with that. So that would mean the column stroke is 400 millimeters. So if I divide that by 2, imagine I have a part which is 200 millimeter long or 8 inches, and I want to bore with a boring bar 200 millimeters. And then a 200 millimeter, that's the maximum bore I can do of 200 millimeters, which is approximately from here to here. Then I'm perfectly square and I'll be within 1/1000 straightness. Now I think the deviation I'm getting here and not being close to 0 is because the ways on the milling machine, probably they have some wear in them, or maybe they are not straight. This ways here, and maybe this is not making full contact. I have this tighten to the maximum, and even with that the servo motor has no problem with the column tighten on the gib, no problem whatsoever, moving this up and down like nothing. It's a 1 kilowatt servo motor I have there. So I'm satisfied with this, and then I'm gonna move the square in the other position to see where I am with that. Take the other measurement and put a shim and see if it comes to 0. Aligning it with the grooves in the table and making sure I'm not hitting this. So maybe a little bit to the left, maybe about this much. Yeah, that looks okay. I'll put this weight here. And I'm putting this weight here because I've noticed when the dial is here up, it's actually able to push just the pressure in the spring and slide the square 1 or 2 thousand. So that's why I'm having this weight, and I'm also not leaving it like that, just actually clamping it here so it's not moving on me and give me a wrong measurement. So I'm gonna do the same on this side. That's about right. Put the nut here. Tight just a little bit, doesn't need to be crazy tight. Now let's put the dial indicator. So I think to find the lowest position I can go, well, this is staying the way. I need to move it further here. Maybe this much. Okay. So how long can I go here? Yeah, that's the lowest point. So let's put this dial here. Okay. I'm gonna put some pressure on it, on that spring inside, and have it 0, clamp the table, and maybe center it. Okay. Okay, we are on 0.